All right. So this is 2.2, number 17. And we are supposed to solve this problem. Yes?
Mm-hmm.
Okay. So first things first, I need to set some variables here. So do algebra to this thing, right? I am fairly confident that I'm going to get 1 over y squared plus 2y plus 1 dy is minus 4x over x squared plus 2 dx.
Okay, this is actually really fortuitous because I just finished this problem, so I want to see if I got it right.
Perfect. I want to know if I got it right too. All right. That seems right to me. Objections?
No.
None.
None. Good. Okay, so now we need to integrate things.
Squiglet.
Squigglies. Okay, so on the left one, I'm going to rewrite that as 1 over y plus 1 squared integrated dy. Everybody with me on that? Okay. And on the one on the right, I'm just going to leave that alone for right now. Okay, then we're going to run a couple u subs. So on the y side, we're going to let u be y plus 1. Then du is going to be dy. On the right, I'm going to let u be right ideas,
X squared plus 2.
seems like. And du then is 2x. So I'm going to factor this minus 4 into a 2 and a minus 2 that I'm pulling out. Pretty good with that?
Mm-hmm.
Okay, so on the... Oops. I lost a dx. Okay, so in here I have that and this are my du, and on the other side, this is my du. So after doing a little bit of calculus, I'm going to have the, well, that's not really strictly speaking calculus. U sub, I guess. That's kind of calculus, right? Is that fair? You
Yeah.
learned substitution calculus, right?
Yep. That's
Okay.
Calc 2.
Really?
Well, for integrals, yeah.
Yeah.
Okay.
Because you don't learn integration until Calc 2.
Is that really true?
Well,
Yeah.
you learn elementary like integration at the end of Calc 1, but you don't learn antiderivatives until Calc 2.
Yeah, you learn like Riemann sums.
Yeah,
Yeah.
you just barely touch on the form of Riemann sums.
Oh, okay. All right. So I have 1 over u squared du is minus 2 times the integral of 1 over u du. I guess it's a
Yeah.
good thing I haven't taught calculus in a while. I probably would have tried to punch to integration by parts in the first semester.
Okay, now the one thing that I had about this is I realized it partway through isn't, and this is a technicality, so you may not care, but isn't it technically required that you use something other than u for one of the sides?
I don't know. Maybe.
Okay.
Safe
Didn't know if it was a strict
product
rule or not.
Hi.
Hi, Joe. I'm Bridget. Hi, everyone.
Your screen name is funny.
Oh, I'm at my work. Let me rename it.
No, it's all good. You can keep it.
You guys can get
I
a
was
taste.
gonna,
Okay.
I was gonna say
Technically,
to Ethan, like you could just put a subscript or a superscript or no, a subscript on one of your variables and they'd be different anyway. So I don't
I usually just use v for the second one, just for the sake of clarity. And that way I can tell which u is which.
I would claim that I did that by using a pink one and a red one.
Okay, fair enough. I'll take that.
But afterwards, it doesn't really matter.
No, I know, but I think that's probably something Jim would get me for.
Yeah, I can
yeah,
see that.
yeah, that's entirely possible. Okay, so here I'm going to have, what's the integral of 1 over u squared? How the hell do you do that?
-1 over u.
Okay, so I have -1 over y plus 1 on this side is going to equal -2 log of the absolute value of
X
u,
squared plus 2.
x squared plus 2 over there. That was a red u. And then I have a plus a constant. On board with that?
Yep, looks good.
Okay, next thing's next. What is my next thing?
You can drop the minuses from both sides.
Oh yeah,
Cool, I'm down with that.
and then inverse them.
Yeah, and then maybe flip
Yep.
both sides over.
Hmm.
That's kind of a weird step. I don't really have a good name for that. So I have y plus
Usually just say
1
inverse.
is 1 over 2 natural log of the absolute value. Oh, good news. X squared plus 2 is what?
Always positive.
So that's x squared plus 2 plus.
I always forget my absolute magnitude signs. Like even if it's not important here, like I always forget them.
So
Oh, and now I'm going to yell at you about something technical.
I have the opposite problem. I always forget to take them off.
This is an absolute value bar. This is a magnitude bar.
Yeah. Well, I knew that.
Those are different. Except in the very dumb case where you think about the real numbers as a one-dimensional vector space over itself, and then they're the same.
Mhm. I was gonna say if you just have a single number in there, they're the same thing.
Yeah. All right. At any rate, I don't actually care about that. I just think it's fun. So then I think I need to subtract 1 to the other side. So I got y is 1 over 2 natural log of x squared plus 2 plus a constant minus 1. And then what? Have I
Solve
answered
for
this
initial
question?
value.
You only answered half of it.
Well, okay. I would argue that I answered the big half anyway.
Yeah.
Yeah, that's true.
I think I'm supposed to do 3 things: solve the IVP, find the interval of validity, and before I solve the IVP, I have to solve the equation, right? So I would say that I have here a general solution to the equation. You guys all with me on that? So now, in order to solve the IVP, how do I do that?
What's your condition?
Good question. I'm scrolling back up. It's y of 1 is minus 1.
Plug them in.
Well, this is bad wording.
So this is kind of where I fell off because you have a -1 and a -1 on both sides and they cancel 0. And then you have all that in the denominator and I don't know how to solve for that.
But remember, Jacob, you can invert that fraction. If you leave the -1s on both sides, you can invert -1 as -1 over 1 or 1 over
Okay,
-1.
I should have done that. I tried doing that with 0 and I was like, wait, can you inverse 0?
Not technically, but if
Yeah.
you leave the -1s on both sides, you can just invert the whole thing and then you can solve it without a denominator.
Yeah, that makes more sense. Should have done that.
Okay, so your claim, Ethan, is that I should flip this whole thing over again?
Yes. That is my claim.
Okay, that's interesting.
I'm sure there's another way you could do it, but this is the only way that really made sense in my head from a like purely mental perspective.
Yeah, okay, let's try it. So if I flip both sides over again, I have -1 is, and then this whole thing needs to get flipped over. So I should have 1 over 1 over 2 natural log of x squared plus 2 plus.
And now I'm seeing the
Sure,
complications.
I'll be
too.
bad.
This feels
Love you.
awful.
Well, then you could multiply it to the. Oh, then you just have the same thing again.
Oh, but I could flip it over again. I bet I should flip it over again. That's got to be a good idea, right? No, because it just goes back to that one. Damn it.
Yeah.
I was really hoping that was a good idea. I was hoping to end up with a recursive formula or something, but it doesn't. That's so
Why not just simplify the fraction and move the c to the top? Move the c to the top.
Okay. So you guys want to do, instead of flipping it all over, you want to say, okay,
Well-
so,
It kind of involves flipping it all over.
oh, before I flip it over though. Yeah,
Yeah.
I think I'm with you. Okay, so you would claim that I want to have a common bottom on this thing, basically.
Mhm.
Oh, I see. Yeah.
Like
I
this.
may. It occurs to me I may have committed an arithmetic error in solving this, but I'm curious to see if it comes out to the same thing.
So I think my inclination on this would be to look at this thing the way that Jacob did initially and say, that would mean that 0 is 1 over 2 natural log of x squared plus 2 plus c.
But then how would you solve for?
There's something wrong
Uh-huh.
Yeah. Then you can't.
because
You can't
one
solve
is not
it.
equal to 0.
Yeah.
Uh-huh.
You've got an algebraic discontinuity.
Yeah.
Does that mean there's no solution?
Uh-huh.
Nice. Awesome. I'm glad to know I didn't do something wrong.
Yeah, no. The answer to this one is that there is a general solution to this equation,
Just
but this
not-
IVP does not have a solution.
Cool.
That happens. It happens, well, not as often as you'd think, but it happens once in a while.
According to the textbook, the solution is y is equivalent to or definitionally equal to -1.
Okay, good. So let's consider that because it is possible that I have not. So certainly what I have here is that this green equation does not have a solution. You guys all with me on that?
That makes sense.
Okay. Now let's go consider whether a constant could solve this thing. Because I have done a bunch of algebraic manipulations. You guys all believe that a bunch of algebra happened?
Yeah.
In that process, I was not keeping particularly careful track of what I was multiplying both sides by or dividing both sides by or any of that stuff. You guys with me on that?
Mhm.
Yeah.
Most of the time, that doesn't matter. In the end, you get a function, you plug in your initial value, there's no problems. It works, you have your solution, it's right there. In the case where you run into one of these, like, okay, I can't solve this equation, that doesn't necessarily mean that the differential equation has no solution. It may just mean that the setup you have for your constant has no solution, which is caused by something you did in the algebra, or at least which is something you could notice if you looked carefully at the algebra. You guys all with me? So let's go back and consider what we did to get here. So my concern is that right here, I should be worried about dividing by y equals -1. Why should I be worried about that? Because given my initial condition, if y was always... Oh, sorry. Why am I writing that? That's insane. Y plus 1 is constantly 0. If I were to divide by y plus 1, right? If y is ever actually equal to -1, I would run into a discontinuity at that point, right? If y was always -1, then I would run into a major problem dividing by y plus 1. I don't know why I keep writing this. I don't know why I keep writing equals there. It's because I'm concerned about when that thing is 0, right?
Mm-hmm.
So notice this first algebra step that I did. I had this thing that I divided both sides by. And that thing is y plus 1 squared.
So you did divide by that.
So I divided by y plus 1 not one time,
Twice.
but twice. You guys with me on that? So
we're really dividing by zeros all around today.
Yeah, exactly. So I started this problem off by dividing by 0. Was I wrong to do that? No. This is how I want you guys to do these. But when they come up with a constant equation that you can't solve, then maybe we have to think harder. We go back, we look. Okay, well, what if y was actually just solid equal to -1? Well, then y prime is 0, right?
Yeah.
Okay, so if I plug those in here, I'm looking at 0 times x squared plus 2 plus 4x times 0.
Yep.
And I'm wondering, is that 0?
I
I'm not
wonder.
sure, man. It's a tough one.
Sure is. Shit. Was I expected to see this at the beginning? Nah.
No.
Does it happen? Yeah.
Is this something we should try like when we start a problem, or only until we realize it doesn't have a solution?
Both approaches are valid. I have a tendency to dive right in and start doing calculus because the vast majority of the time this doesn't happen.
Yeah.
If you want to check first and maybe save yourself some work once in a while, it's probably not a bad idea. If you're gonna be a mathematician, you might want to check first. If you're gonna be an engineer, probably don't need to check first. Reason being, in the kind of engineering style problems, this solution of y is constantly -1 usually just means that you didn't turn anything on. Right? That's like a steady state. That's like the concentration of CO2 in the air is constant, or the position of the mass is constant, or the displacement of the spring is constant. Like, this is a whole bunch of things that are generally not very interesting to look at from an engineering perspective because nothing's going on. You guys see that?
Mm-hmm.
Yeah.
The ones that you should be worried about are when y is constantly 0. Because those do come up in applications sometimes. If you set up a bunch of differential equations and then you discover that the population is constantly 0, you might want to consider what's going on in that case. Right? Like, you might model the population of wombats in your room by the y is constantly 0 function, right? I don't know where you're at, Bridget. Are you in a place where there are wombats?
Nah, I work in a cheese factory, Joe.
You work in a cheese factory?
I think.
That's hella cool. Where?
Let me see if I can turn my screen around so you guys can see my.
Wait, can we see a cheese factory?
No, not quite. You can see some silos. Okay, I'm on my doc, so